In this section, we're looking at algebra, specifically starting with adding and subtracting polynomials. So when we're working with polynomials for adding and subtracting, we can only add and subtract like terms. Like terms need to have the same variable and the same exponent. We can only combine like terms when we're adding and subtracting. So we can't combine things that don't have the same variable and exponent attached to them. So we're going to take a look at an example here of some pairs of numbers, and we'll determine which are like terms and which aren't. 4 and negative 7 are like terms. This is because 4 and negative 7 don't include any variable, and thus, because there's no variable attached to them, they have the same variable technically, or in this case, lack thereof. So these are like. 3x and 3 would not be like terms. Well, they both have the number 3 attached to them. X is a variable, and the number 3 over here by itself does not have a variable. These are not like. In C, negative 2x and pi x. Negative 2 and pi are both numbers. They are not variables. Pi is a number. So negative 2x and pi x are both variables, both numbers, and they both have a variable of x. Same power on the variable, it's just a plain old x, or x to the power of 1 technically. And in both cases, these would then be like terms. 0.3 squared and x squared, while they both have a squared on them, they don't share the same variable. There's no variable here. There is a variable here. Thus, these would not be like. In the next example, 2x squared minus 4x and negative 4x cubed, The x squared and the x cubed are different. They are the same variable of x, but they don't contain the same exponent. Thus, they are not like terms. In the next case, we have 6x squared and negative 7x squared. In both cases, they have an x squared. They would be like terms. In G, we have 3xy squared and 4x squared y. Well, they have the same letters, x and y. The exponents are different. This is an x to the 1, this is an x to the power of 2. And this is a y to the power of 2, this is a y to the power of 1. The exponents don't match on the variables, thus these are not like. And finally, we got 9x cubed and 10x cubed. Both of them have an x. Both of those x's are cubed. These are like terms. So in any of these cases where we have like terms, we could add or subtract those. We cannot add or subtract the not like terms. So as an example of actually adding and subtracting some of these terms, we'll take a look at a couple of simplifications. So when you're asked to simplify, that means you're going to be collecting any like terms, adding and subtracting them as necessary. So in the first case, we have a negative 3x squared and a plus 4x squared. We're only worried about adding and subtracting the numerical portion, the coefficient of them. We have negative 3 and we have plus 4. Negative 3 plus 4 is 1, and then it's an x squared. So there's 1x squared there. These are done. I'll make a little check with them. I then have negative 2 plus 9. Both of them have an x on them, but we're only worried about adding and subtracting the numerical portion. So negative 2 plus 9x is going to give me plus 7x. And there's this equation simplified. Now the reason why the x doesn't get subtracted as well is because this is a representation. The x is a number of x's. So we have negative 2x's, we have 9x's. That's like saying I have 3 pens and I can add, let's say I have 2 pens and I have 1 pen. If I add them, I get 3 pens. If I have 3 pens and I take away 2 pens, I still have 1 pen. The x value is in relation to the item, so that doesn't get added or subtracted. It's just the number in front of them. In the case of B here, we have 4x plus 6x squared minus 3 minus 2x minus 6x squared. Here you may wish to collect like terms. This is not a necessary step as long as you get all the matching pairs together in this case. I'm going to collect the like terms. I'm going to start with x at the highest exponent as well, just for the sake of neatness. So this is 6x squared. I didn't have to put the plus there because it is a positive number. This is minus 6x squared. So those two are done. Then we got x's as the next power. This is a positive 4x. There's no sign in front, so we assume it's a positive 4. Positive 4x. We got a minus 2x. And then just a lonely old minus 3 there. 6x squared minus 6x, that will get us a 0x squared. So we could write that down. We want to. And then 4 and minus 2 is going to give us plus 2x. And then a minus 3. We don't need to write the plus or the 0x squared here. This is not required. My answer should just look like this. We don't put the 0 parts in as they become just an excessive piece. So you could go right from this very first line to this and still get the same answer. This rearranging step is optional. If you have trouble getting them correct without rearranging, then collect your like terms first, then do your steps. If you have trouble with the 0 part, then write that in and then remove it at the end. But this is the answer that I would like to see, and as long as you're getting that answer correct consistently, I'm happy. The same over here. This one here, we would normally just write x squared plus 7x, because if I have a pencil on my page or I have 1 pencil on my page, it means the same thing. It's the same idea here. I have 1x squared or I have x squared. Both of them mean the same thing. Now, in terms of why this actually works, it's sometimes good to think of these. We use the term x squared here, and when we talk about an x squared, we can actually think of a square. So this is three x squareds. So 3 squares that we owe. We're negative 3. So these are minus 3 squares. And then the opposites of minus 3 squares would be our 1, 2, 3, 4 positive squares. So negatives and positives will cancel each other out, and we're left with 1 positive square. We can't add a square to an x, so if an x squared means a square, and x could just be a line, you wouldn't just add a line to a square. If I take a square and add a line, oh, it's a ladle. But what if I add the line in a different spot? It doesn't make any sense in terms of a shape, so we don't add the x and the x squared. They're not like terms. So some people find that useful in terms of understanding it. If that makes it confusing for you, just ignore that last piece there about the whole boxes. In the last part of this one, we're just going to look at when we have the case of dealing with brackets with no numbers in between the brackets, in front of the brackets here. So here we have no number in front of a bracket, no number, just a plus sign, no number, just a minus sign in front of the bracket. So in the cases where we have a plus sign or no sign in front, like the first two, we just drop the brackets. Just get rid of them. They're not required. In the case where we have a minus sign in front, like the third one here, we're going to switch all the signs in that bracket around. So they're going to become their opposite. So I should probably note, switch all the signs in that bracket to their opposite. That looks bad. Okay, so we're going to just switch them to the opposite. So if we take this first one, we just drop the brackets. We have 4x plus 3x squared minus 2. In the next one, we can get rid of the brackets, so we have a plus. I'm ignoring the plus sign as well. I'm just looking at the 5. This is a positive 5. So this is plus 5x squared minus 3x plus 1. So I'm not regarding this plus sign here. I'm looking at the sign in front of the 5, which there is none, so it's a positive 5. Thus, I got a plus 5 here. In the last bracket, it's negative, so this positive 7 becomes negative 7x squared. Negative 6 becomes plus 6, and positive 4x becomes negative 4x. So I have all those now out of their brackets, and I can collect my like terms and simplify this. So I have a 3x squared plus a 5x squared. That's going to give me 8x squared minus 7x squared is going to leave me with x squared. And again, if you want to collect like terms, you're perfectly fine to do that. If you're comfortable not collecting like terms, just make sure you have the correct answer and it will be all good. We have a 4x and we have a minus 3x and a minus 4x. 4 minus 3 is going to give me 1 minus 4 is going to give me negative 3 x's. So those are done. And then finally, I have my negative 2 plus 1 plus 6. Negative 2 plus 1 is negative 1 plus 6 is going to give me positive 5. X squared minus 3x plus 5 would be that equation simplified.